Hello everyone, my name is Grzegorz Piwowarek. If you want to find me anywhere online, you can use this Piwowarek handle, or for English speaking people, something like Piwowarek. Today we will be speaking about exceptions and ideas from functional programming languages that we can adapt in the world of Java. I'm an open source committer. I have quite a few lines in AssertJ and Waiver. Recently, we started a new project that connects those two projects together, which is AssertJ Waiver. So far, not much is done here, but we are assembling a team. So if you want to contribute, it's a good moment to join. I'm also blogging at my site for comprehension for not quite a long time. The site is running on for like 1 month, and I'm helping with Baldung site as a senior editor in there. So the topic for today is exceptions. Exceptions, well, they have their own use cases. They solve some problems, but there are some problems associated with them. So, for example, when the exception is thrown, it's kind of in what it does. It creates some invisible routes in the code. It's very hard to see where it will be thrown and when it will be caught. Well, especially in the case of unchecked exceptions, if you don't catch them on the spot, they can fly around your whole code base, creating unexpected paths. Well, that might result in unexpected results of your software. And obviously, if your exception is thrown from some methods, this obviously should be kind of treated as a possible exit point, as possible return value. And it becomes super hard to debug and often test. Also, another problem is that if you deal with exceptions, for example, in asynchronous environments, sometimes it's very easy for them to get lost, to get swallowed in a separate thread. Another very common critique when it comes to exceptions is the fact that the try-catch statements behave kind of like a go-tos. So in the place where you just catch an exception, it's a jump from one spot to the other. And people started noticing this quite a long time ago. So, for example, you can see here a quote from Joel Spolsky. This is the guy behind a site as Stack Overflow. You probably know this one. So people started noticing that the overusing mechanisms for exceptions can be harmful for your code base in the long term. This is the case especially in Java, because the mechanism is overused. We use exceptions, for example, for modeling an absence. Well, no such element exception is an example of it. We often use exceptions for modeling known business cases. So, for example, the bus arrives, the bus is empty, but instead of doing something else, we just throw an exception. While it's perfectly fine, well, it's not an exception, it's something normal that can happen, but we still kind of tend to overuse it. Same with modeling alternative paths in our code. But besides the fact that exceptions can be, well, surprising for us or unexpected, there is one more interesting thing about them. Well, the instantiating of them is not very cheap. Do you have any idea why is that? Exactly. The problem with instantiating exceptions, or generally variables, is that at some point there is one method, filling stack trace, which essentially, well, makes instantiating them much different from normal purges, okay? Because we are not only create an object, but we also need to run through the whole stack trace and collect everything in there. And, well, we don't often think about that because it doesn't harm our systems often. But, for example, there is one interesting case of one guy that was developing netty, and he was benchmarking the situations. So he created like a set of benchmarks and compared situations where he was creating a lot of normal variables, instantiating them. There was another case when he was instantiating variables once and just reusing them. And the last one when he was creating static variables without any stack trace. So on the left, on those 3 cases on the left, you can see that there are some bars there. They are very, very small. You can't see them, but they are there. And the numbers there are around 0 operations per second. Well, in this particular benchmark, you can find the details if you follow the link. But on the other side, you have the case where he was just reusing the already created exception without any stack trace. And numbers are there like 60K, okay? So the difference can be huge. So over the years, we kind of started noticing some problems with exceptions. We found out quite a lot of anti-patterns that can happen here. So, for example, this includes destructive wrapping. It includes catch and do nothing with an exception, throwing these exceptions in finally blocks, and so on and so on. The point here is not to go through all of them, but to mention that there's quite a lot of them. Well, that quite a lot of problematic situations were identified. But, for example, there are other languages, like Go, that made some interesting design decisions regarding exception handling. So in Go, basically, you don't have something like exceptions. You have an errors, and the cool thing about Go is that you can return more than one value from a function. So in this case, if we have such a simple method like foo that does something with a string, you can see on the right that it returns a string or an error. Well, the handling can look, not very nice, because the language is basically slightly, it's a lower level language. It's not a high level language as Java. So simply in this case, we just do a simple null check and check if the error was there. Well, some might argue that it doesn't look very good. Well, because it doesn't, to be honest. But it solves quite a lot of problems. There's no any special mechanism for exception handling. The flow of the program is not disrupted. It's simply another object returned from function. So if you think about your methods as, for example, pipes, in Go, if you look at the end of the pipe and basically observe if anything comes out of it, you are pretty much safe. But if you have unchecked exceptions flowing all around, that can be thrown all around the place, it turns out it's just like this pipe, but that can pretty much leak from any possible spot. Well, if you don't catch them exactly on the same spot. So that's quite an interesting approach that makes exception handling much easier. But of course, there are still situations where we need to signalize something, really exceptional. So of course they reserve the panic keyword for that. But this is designed to be used only in situations where you really don't expect anyone to recover from that. Well, it's possible using deferred methods in Go, but the general the purpose of it is so that you don't handle such situations. So since we are on a pretty much Java conference, probably I don't need to advocate the benefits of static typing here, but let's spend a second on it. So, as you know, there is the big war often between static strong typing and weak dynamic typing. So especially here, I'd like to recall some advantages of static typing that we often tend to not leverage or forget about. So, for example, recently I've been reading a lot of blogs. For example, there was an article from Uncle Bob where he was bashing Kotlin or Swift for being too statically typed. And the main the idea behind the whole article was that we shouldn't use static typing as a replacement for writing tests. Well, I don't fully agree on that. In this war, I'm on the static typing side, because there's one thing that many people tend to forget about, is that how often you run your tests and how long do they last. Because of course you can forget about types, you can write code using dynamic typing, and you can write tests for that. That basically enforce same constraints as types would. But the problem with that is that you need to run your tests and that they last. And it's problematic, because if your tests last longer than a few seconds, you won't probably run them quite often. the cool thing about static typing is that it's like having tests basically that run all over time, almost immediately. And if you ever been like familiar with the agile approach, and if you ever attended like a Scrum Master training or something, you know that the main benefit of the whole approach is the fact that we get our feedback very quick. Okay, we get feedback after every iteration and not after the whole project life cycle. So this is a good thing to remember about, because what we tend to write often in Java is something like this. Okay, because if you really want to leverage the power of static typing, well, you need to make some effort, and obviously we often tend to not make that effort. So we end up with stuff like this. So instead of a strongly typed language, we write stringly typed code, which doesn't really give us any like benefits, okay? Any benefits that types would give us. So instead of there's an approach called type-driven development, where you actually leverage types for that allow you to perform some small additional checks on the domain. So in this case, instead of representing everything as strings, you can use types for making sure that this string actually, doesn't represent any a random sequence of characters, but maybe represents a surname, maybe represents an address, phone number, and so on. And type safety saves us in those moments, because if we pass a string that's a surname to a method that accepts a phone number, this will not compile. And this is something worth remembering. And actually in Java, we started noticing recently, around 3 years ago, that we actually can use types to express something more. So for example, the tool called optional was introduced, where, we were able to finally, we realized that we can express optionality using, types and not null pointers, not nulls, which is actually quite interesting, because Java was always trying to like hide the abstraction of pointers to us. But when it comes to null, suddenly the pointers are out there. So we have optionals. We learned how to use it. Optionals were created to represent values that can be, exist or not. We represent optionality. So why not use the same approach to different scenarios? For example, for exception handling. We obviously don't like try catches. So for example, Scala and other languages came up with solutions for that. Actually, so the natural way was to create something that would allow us to handle exceptions. So when optionals can be present or not, with try, this time it can be either a success or a failure. And the whole API and everything is very similar to optional, but the whole idea behind this to provide us an easier way of encapsulating the ugly exception handling. The interesting part is that try doesn't really exist in like functional languages that are purely functional, and they don't have like a normal exceptions. It exists only, it's valid only in Java world, where we actually need to somehow encapsulate the exception handling and provide some nicer APIs for that. So that's how it looks in Scala. In Scala, we have something called like a sealed keyword, which pretty much allows us to like restrict the type hierarchy to only predefined types. In Java, we can't do this, so there are some other workarounds for that. For example, this is what they did in Waiver, which is an ex-Java slang library. They used like interfaces for representing the hierarchy, and somehow it works. And if you were to create some tool like this, you can have a look at this. So eventually, you would just create a static factory method that try catches some all possible like exceptions that can be thrown in a provided action, in this case represented by a checked function, and then pass further an instance of success or a failure if some failure indeed occurred. And if we look through the whole like try APIs, we will discover that we have a lot of methods that we Well, we already are familiar with, because if we're playing with optionals or other or functional languages, those methods like map, flat map, filter, they are all like the part of the canon. So everything here should be quite familiar. We can use map for well, specifying declaratively what to do with the value, well, that's inside a try object. We can use the filter to apply to some additional like filtering on this value, and or else if we want to define a default, and so on and so on. So this obviously will look very familiar if you've been already playing with optional streams, completable features on maybe waiver. And now let's have a look at this, how it looks like from the consumer side. So usually those types like try, optionals, they are not designed to be stored as fields or passed as method arguments, but they are mostly designed to be used as return types. Okay, you return to a consumer, to a user, a value, encapsulate it in an object, well, that encapsulates also some kind of computational context where the value is in. In this case, we are dealing with exceptions. So for example, if we want to call a get search results and it returns a list, well, usually we have a choice. Well, in this case, we are throwing IO exception if something gets wrong, because we are obviously fetching this results somewhere from the web. So in such case, instead of just throwing an exception, we could package our list in a try object, which already informs your consumers that something can go wrong. And in this case, as you can see, we are calling this method over there. And now the cool thing about that is that consumer has a choice. If you are throwing an exception, well, you some kind of enforce users to deal with this situation in a particular way. But if you are wrapping the result in a try object, it's up to a to consumer how to deal with that. So obviously you can easily rethrow an exception if you want, but usually you would rather want to leverage quite a rich API. So in this case, for example, we decided to specify a callback that should be run when something went wrong here, and specify fetch a value from inside if it's fine, or just return a list if something went wrong. Well, list with some values that we know beforehand. But if we look at this tool from the producer side, it's also quite easy to use. Because let's have a look now at the internal implementation of get search results. You can see we are basically looking up this information in Google or on DuckDuckGo. So we have, let's say, those APIs exposed to different methods. There's one method that throws no such element exception or IO exception, and get from DuckDuckGo throws IO exception. So such tools are also very handy to use if you create them. So in this case, well, it's super easy because you simply you need to initialize the try with some operation, and then you can leverage a very nice declarative API for composing your results together. So in this case, we encapsulated our operation in a try object. But now, for example, we know what we should do if we encounter not such element exception. In this case, this was used basically for expressing absence of some value. So we can leverage the API and translate the exception to the empty list. Well, by inspecting the implementation of this method, or just by reading the documentation, we discovered that it can throw NSA forbidden exception. So you already know how to handle this. So we specify another line, recover, and then finally we compose it with another try that will be run only when something gets wrong. So just similarly as in case with Eric's Java, if you've been playing, the API is very rich and allows you to compose such computations very easily. not only to like consume them from the consumer side. But there are some corner cases to this. For example, imagine that if you put a lot of, let's say that all your methods return try instead of throwing exceptions. Obviously, at some point, you will end up with a situation where here you have, one method returns a try, but there is another method that, needs to be handled inside, while you are processing the first try already. And, the natural thing here would be to wrap this one in another try. But this can be quite complicated, because if you have a look at the type here, you will end up seeing, try from try and input stream. Well, the first thing might be, your first thought might be that, since we have try and try, we are super safe, right? No, not really. This is actually the case where static typing, it can be problematic and not helpful. So in such cases, we need to remember that exists special tools for dealing with, we have those tools nested. And in this case, this one is called flatmap. And if you ever encounter a situation where you have nested tries, optionals, or other stuff, usually you want to use a flatmap to get rid out of this problem. Another cool thing is that if you work with functional programming languages and those tools are modeled using sealed hierarchies, this is the case where compiler can help us a lot, especially in the case of pattern matching. Because another approach to consuming a try object would be to, pattern match it. So basically, specify declaratively what should be done in the case of a success and in the case of failure. Well, in Java, we need to remember to basically pretty much specify all possible types. But if we were working with, for example, Scala, the compiler would tell us remind us if we didn't specify all possible cases, or if this wasn't exhaustive. So this was the case when we actually wanted to somehow encapsulate exception handling in Java. But at the beginning, we had a look at the example in Go. What if we really tried to simulate that fill in Java? Well, we could use a tuple. We could simulate returning two values using a tuple. So in this case, if you have a look at the find1 method, there's a tuple that returns a person and an error object. But there's a problem with that. Because if you try to consume this, we end up with two null checks. And this is pretty much because if you deal with tuples, you kind of expect them to hold values that are non-nullable. So this doesn't look very cool. It actually gives you this Java feel, this bad Java feel that you don't want here. So there's another idea. There's a dedicated tool that can be used in such situations. It's called either. This is it's quite kind of different tool than optionals, tries, and other stuff like this. Because in optionals, you're kind of biased towards one of two states. Optionals can be present and empty. Tries can be either success and a failure. And somewhere here there is we lean towards when we deal with optionals, we lean towards stuff where the optional is present, to dealing with situations when the value is present. When we deal with try, we kind of expect it, we hope it will be, something will be inside. But with either, it's kind of different. It's totally unbiased, so eithers are tools that can represent us a value that can be one out of two types. And it doesn't force us which one is the good one. So basically, try is a kind of, it's also like the specialized case of an either, but dedicated for exception handling. But it turns out that either can be used in a much bigger variety of cases. And again, since we don't have sealed hierarchies in Java, we need to make our come up with some different solution. This is how it looks in Waiver. It was implemented using interfaces. And now, whenever we want to instantiate something like this, there is not really a very nice, cool API to leverage for composing different cases. We need to instantiate it either using the left method or right one. Well, obviously, according in the appropriate context. And now, if we have a look at the API, we obviously get all those familiar methods that are in optional, so try, but there are two very important ones that you need to remember about. There's the left and right projection. Because since either is unbiased, well, if you call a map on it, well, which value will it work with? Well, you wouldn't know. So this is the very nice thing, because when we consume an either, we can specify basically which value would we like to work on, the one on the left or the one on the right. And this is where projections kick in, because if you want to work on a, let's say, in the value that was on the left one, you use left projection. And then you continue with the familiar API, with map, flat maps, filters, and so on. And if you work with the right value, you start obviously with the right projection. And obviously you can find, well, some more generic methods that work for both cases at the same time, but they are not super handy to use and they are not very readable, because if you need to, well, pass two lambda expressions to one method, it's not super obvious which one does, which one works on which case. Same for faults, but still there's a possibility often of doing some additional processing at this point. Obviously, we have those methods like getLeft, getRight, but those should be rather, well, you can use them only if you really know what you are doing. Same with optionals and tries. If you call .get and an optional, basically you kind of decide to abandon all this like good things that optional gives you. So if you call get an optional, instead of like nice like optionality handling, you get basically no such element exception. So if you use a get, essentially there's a syntactic sugar over that changes null pointer exception to a no such element exception. Same here, use it only when you actually know what you are doing. It means when you want to bypass basically all checks that either gives you. So how would it look like in real world? Either is not dedicated to use with exception, but more with an error object. So such an error object in Scala would look like this. It's essentially one line. It's a case class that has, for example, some message and something else. Unfortunately, we are working in Java, so we need to write much more code to achieve the same. Unfortunately, it was one line. Here is like over 20. Too bad. But we have a Lombok, so we can simplify this a bit. And now, let's have a look how to actually use it. So again, we have the method that we were talking about previously, get search results, that wraps basically a list into a try object. But let's try to represent this one using an either. So in this case, we abandon like all this exception thing. We don't think about exceptions now, but we return either a list of ready results or our fetch error defined earlier. So in this case, how the consumption of either looks like is that you call a method, you probably store the result somewhere, and now, in this case, we want to handle the, well, in this case, the successful case, the right side. You create a projection, and then you leverage the declarative API to do whatever you want with that. And if you want to focus on exceptions or on errors, you start with the left projection. So it looks much better and it's much more convenient to use than two null checks, as in the case of tuples that I showed a few minutes ago. Of course, we don't call two methods, well, the same method twice. We probably store this result somewhere along the way. Also, the cool thing about either is that you don't need to use it for returning errors. So another like popular scenario that you can use it with is modeling alternative paths. So for example, imagine a situation where you try to resolve an URL and you want to, well, basically query a DNS server and get a result from it. So what can happen over there somewhere on the line is when you call a DNS, it can either respond you with everything or pretty much go further and ask another DF and DNS for more details. And so this, for example, could be represented with an either that returns either a ready result or a DNS. And this is actually used in practice. If you look into Scala sources, you will see that the tail calls, tailwork, use this either internally for managing tail recursive calls. So if you, well, you can ignore all of this, but you can see that the tail rec returns either another tail rec, well, recursive tail rec, or a result. So it turns out it can be used in like not only in like functional programming presentations. Another case is the absence modeling. We often tend to, well, exceptions are overused, especially for absence modeling. If you have a look at methods like find one or value of, you will often see that they throw exceptions. No such element, number format exception. But if you inspect actually the message that we got from exception, it's nothing really that gives us any additional information. It's nothing. We just get no such element exception, and this is the only information that we get. And this is problematic because again we enforce users, consumers of our APIs, to handle, well, such situation in this particular way. So why not give our users something more flexible where they can decide what they want to do with this particular situation? So it turns out that exception modeling, well, absence modeling can be easily done with optionals. So next time, instead of throwing no such element exception, you might consider to simply return an optional of type person. Same again, if you are parsing, let's say, a string to an integer, you might return an optional because, well, in this case, if you look at the integer class, the exception doesn't really give you any additional information what was hard to parse. It just gives you information that, oops, I couldn't parse. Well, at least is this and not null. So this is another idea that's worth considering. And what pretty much worries me a bit, that if you look into a GitHub and try to pull some statistics from it, well, some very naive statistics, you will see that there is over like 500,000 no such element exceptions being thrown over the different code bases. Same with not found exceptions, not even mentioning any different kinds of exceptions that could be thrown, well, in the case of absence modeling, not mentioning nulls too. So the problem is here, well, what if you really want to do that, but your language doesn't really let you do this? Well, the first very abrupt option is to switch a language, but obviously it is not always an option. If you go to your boss and if you work for a corporate client, you don't go and say, oh, boss, since today I'm writing Haskell and not Java 5. So another option, of course, is building it yourself for your language, but this is also probably not, you probably don't want to start from scratch. So the very good place to start with is the waiver library. Those examples that were shown here were all taken from waiver. A few years ago, whenever we wanted to play with like functional stuff in Java, we would start with attaching Guava to your project. But now, since the addition of functional interfaces and lambdas, it's not that necessary, but it allowed another libraries to pop out. And this is the case with waiver. Waiver basically brings all good stuff from Scala into Java and allows you to use it on an everyday basis. You have tools like optionals, tries, either, homemade pattern matching, set of persistent collections, and quite a nice bunch of different utils. So every time I start a new project in Java, waiver is one of the first things that goes into the project. So another thing is that you can actually make some pressure on the creators of Java. Remember that there is something like JCP, Java Community Process, and that this is the procedure that, for example, made lambdas happen or Java time. Okay, this was something that's sprinkled from community and made its way into Java. And you can see that it's working. And actually, if you recently there is on YouTube the new presentation from Brian Getz about pattern matching in Java. So those ideas are slowly pulled into the language. And if you like some, well, you can make an impact. well, small one, but if you take all of them, those small ones, you eventually can change something. So at this point, the few takeaways that I'd like you to remember about is that, well, exceptions in Java and in general were kind of dedicated to, well, exceptional situations, and not to, well, not to like representing something, well, like known business cases. But if you are already playing with code that can return and can throw exceptions, a try can be a nice approach for handling this one. If you are dealing with a lot of like absence optionality in your code, you can use optionals for avoiding exception handling. And for more advanced scenarios, or you can use either whenever you want to return, well, error objects, or simply model more advanced alternative process handling of some situation, business logic. Also, another thing I'd like to remember about that, the waiver is now replacing Guava. It's getting more and more popular. Now I think it reached recently over 1K stars on GitHub. So definitely you should consider throwing this one into your project. Since the new version, it will be cut into smaller pieces. So you won't need to like suck in the whole library, just all those interesting tools that you would like to use. So that will be this for today. And I hope that I gave you some ideas that you could implement in your own systems. The important thing to remember is that those are not silver bullets, okay? So the best good practice that you can use in your everyday job is the common sense, okay? So try those tools. If you like them, if it works, use them. If not, well, write me why. So I hope I helped you, and well, we have time for some questions. Thank you.
Dziękujemy za wykład i na kolejny zapraszamy o godzinie 15. A teraz przerwa kawowa. 2 pytania, to już lecę. Ale gdzie?
Oh, I've got quite a few questions actually, because first of all, when I see the code for this try, it's actually a syntactic sugar for actually trying and throwing and catching exceptions. So as far as I understand, the exception object will be created all the same, so it doesn't save us from overheads which linked to instantiating this exception object. So I don't think it's quite a, benefit of using this.
Okay. So first things first, as I said, the try exists basically as a middleman between like either and other options, because, well, when you work with Java, well, you can't get rid of exceptions. You'll use libraries, you use code of other teams that have different conventions, so you can't get rid of exceptions at all. First thing, the cost of instantiating exceptions is not really that painful if you don't do this in a loop all over again. So try, yes, it was dedicated to be used in situations where you need to deal with exceptions, but you don't really want to do this in an old Java way, because I mean, I don't think there are many people over there that really like that can say that they really like try catch. So yeah, this is just the idea that where you use basically types to represent something, encapsulate, and not deal with the pain of try-catch and everyday life. At the beginning, when you start playing with tools like this, it feels kind of weird because it's basically a different paradigm. But after some time, when you familiarize yourself with this, it becomes super easy and natural. Because at the end of the day, this is declarative. You don't just go manual, you don't tell your code to catch here, throw there, or do something else. You just specify, I want this and that to be done if something bad happens, and if something bad happened, do something else. So yeah, we don't get rid of exceptions. We just encapsulate the pain that usually need to happen when we are dealing with them.
Okay, and the next one is I actually have C# background, and for me those Java checked unchecked exception were abomination, to be honest. I had a real pain to deal with it, and well, for me, every method can actually produce an exception. It can be, I don't know, array out of bounds exception, whatever. You can call to string on null or something like that. And if we use this try or either or whatever, won't we end up just returning this try from every single method which, you know, do anything?
That's a very good question, because well, this is where we end up to some discussions and problems with static typing. This is basically the main argument that people raise when you show the advantages of static typing, because sometimes you simply need to push something all around your code base. It can be especially painful in the cases if you know that the exception can't be from there, but you still need to pass this try or try catch everything because you have throws in your method signature. And as I said, this is the moment where you need to you have two sides. Okay, here you can either not use anything or use try. So obviously, just apply a common sense to it, because if you know that this exception can be propagated far away, along the multiple layers of your code base, probably this is not the good idea for using tries or eithers. Okay. So yeah, the main idea is to keep common sense. And yes, this is definitely a downside of static typing. In general, because sometimes you just don't want to write this stuff all over again because it clutters code. So unfortunately, I don't have a clear answer for you, but we all know that this can be problematic, and just use a common sense in such situations. I've seen code bases where, for example, exceptions were used for driving the whole logic of the program. For example, I've seen recently someone playing with Spring SPL language, and they were trying to do something all over it, but the pain of going through 20 layers of abstractions were it was too painful, so they were just throwing exceptions to bypass that, to make this to not just refactor the whole code base. So yeah, at the end of the day, yes, it's a problem, and just use a common sense.
Okay, thanks. And the last one, do you have any examples on GitHub or wherever to look at the code, how it looks with applying all these tools?
First thing, there's one very good tutorial. I think I forgot its name. It's called Neophyte's Guide to Scala, and it goes through optionals, tries, eithers, pattern matching, and other stuff. This is a very good place to start at. Quite a lot of cases are explained on the waivers blog. This is especially useful because, for example, in this case, you are using a waiver library that you would probably want to include to your project. From me, if you want to look something, you can go to my GitHub, and I have, for example, live code snippets from live coding session that I did at Devox, and you can find some other stuff here. But I think I would start with the waiver blog and documentation, which is growing.
Thanks.